Well, hello friends. Welcome back to the program. Today we are going to be investigating a compiler problem because I noticed that it's no longer possible to compile GUI programs in Hack Studio. So the simple program here, that just a command line program, is fine, but as soon as you include libgui application and try to build again, then things fall apart and we get an internal compiler error. So today we're going to be investigating what the heck's going on and hopefully fixing this issue. We've seen internal compiler errors in GCC before, and every single time it was us doing something wrong in our standard C library. So I'm pretty sure that's what it's going to be today as well. I don't really know when this broke, but at some point it did. It may be that since we've updated to GCC 10 after that came out, and we haven't really been testing building GUI apps inside Serenity since then, so I don't know. Anyway, we're just going to work our way backwards from the error and see what's going on. So we have an internal compiler error in MPFR from real at realmpfr.c line 54. So that is plenty of information to go on, I guess. And we do have a backtrace here as well, which is cool. So this is GCC doing something or other, and evaluating constant expression, sure. And then it's trying to do constant folding, maybe, and that calls real from MPFR, which then has an internal error here. I don't know. I'm not a compiler guy, so I'm not super sure about how these things work or what's going on here, but we're just gonna see what we can do. So we have our GCC port here that we built. That's what we're running inside. Here's the source directory, patched for Serenity, of course. So I guess we'll just start by looking in realmpfr.c, like the error mentions. Okay, so that's here. Line 54. All right, so what's going on here? This is MPFR from real, and it's asserting that ret should be 0. Okay, so what is MPFR? It's a multi-precision floating point reliable library. Well, if it is reliable, then probably we're the ones at fault. Okay, so it's some kind of floating point math library thing. I'm guessing that this is like construct an MPFR number object from a real number, or whatever real is. Maybe some GCC type. Okay, and then create a character buffer, and this is infinity and nan, so I don't know if those are relevant here. And then we do real to hexadecimal into the buffer. So presumably this here is like some GCC internal representation of a real number, and we turn that into a string, and then we call some MPFR API to create an MPFR object from that string that we just serialized. So yeah. So they use a string as an intermediate type. So we have a GCC real thing, convert that to a string, and convert that string to an MPFR, and then we get a failure in MPFR, presumably. And this is expected to always work. So I guess what does MPFR setstr do? Hard grep. Oh, we have an MPFR directory here. I guess we can just go in there. Oh wait, did I look at everything now? Wait. Let's see this. A lot of auto tests and stuff here. Let's grab for C files only. I'm not sure that helped actually. Okay, so that's the call, and then I guess we have the source code of MPFR in the tree. All right, that's fine. Source grep. Set stir. That's probably there. All right. So set stir. This is the MPFR object thingy, I guess. There's a string, here's a base, and whatever this is, I don't know, rounding technique or something. How about we just print out what's coming in here so we can take a look at it? So, because I'm kind of curious, like, what are we even sending this thing? Let's just do this. It's not terribly difficult to incremental build GCC. If I remember correctly, you just have to remove some files and make again. So we'll print this thing out, and we could at least see what we're working with. I don't know that these parts here are even interesting. Although let's see, what is this thing? Stir to fur. Set a floating point number from a string. Stir to fur. Okay, so this calls parse string. And then parse string to MPFR. And then free to parse string, sure. And then, I don't know, there's some overflow handling, and here's some commented out code, basically, when there's a huge overflow. That's interesting. I didn't know that there was a distinction between overflow and huge overflow. All right, so yeah, I think we're just going to take a look at what's coming into this function. So the way that we rebuild GCC, you have to delete the old GCC binary, which is somewhere in here, and it's called xgcc. Right, so in here, so we delete that, and you also have to delete the cc1, I think. But then if you do that, then you can just make and test your path to Serenity root install. Oh shit, wait, I have to put my toolchain in path as well. Toolchain local bin. All right. So I think if we only touch that, it won't rebuild that much. Like less than a minute's worth of rebuild. Hopefully. And then maybe we'll be able to, yeah, there we go. Okay, so with this, we should be able to get printfs of everything going into that function. Let's see if that works now. I hope I did the rebuild thing correctly. So I guess I should have, maybe I should prepare this to make it easy for myself to test it. I didn't get any debug printfs. Oh, dang it. All right. Did I need to delete something more? Oh, shit. Wait. we're doing a C++ compile, and I was deleting the C compiler. So we have to do that. Actually, delete XG++ and CC1+. Last time I was messing with this, I think I was compiling some C program that didn't work, so I was just deleting the C compiler. But as you can see there, like just doing a relink of those missing binaries is really fast. Main. All right, make, and okay, here we go. So what? Okay, so I guess this is the string format, the intermediate string representation of an MPFR. So what is this, like a hex? Maybe this is like the integer part, and then here comes the fraction. Not really sure how to interpret these. So it looks like a hexadecimal number followed by a P, followed by a dash, or is that a sign maybe? Followed by exponent. Let's see. So I think this is like some internal representation probably. It's not really meaningful to me. So something goes wrong when we try to set this input. So this is the very last one that goes into MPFR setster. So presumably like all of these succeed and this one fails. And the thing that stands out about it is that it doesn't have a digit at the end. These guys all do. So that's something to work with. So where does that string come from? Let's see. So what was this? MPFR source real. No, wait. Real MPFR. This is where we started, line 54, right? Okay, so the input to this function looks weird, and the input comes from real to hexadecimal, presumably. So let's find that function. Real.c looks good. Real to hexadecimal. Okay, render R as a hexadecimal floating point constant. Blah, blah, blah. Okay, so it renders this real value into a string buffer, presumably. Okay, so here is 0, infinity, nan, blah, blah. And then if it's just a regular old number with a fraction, then let's see. Then what are we doing here? So P points to the start of the buffer. If it's a negative number, we add the minus, and then comes the 0x0. So we're building up this string right here, right? 0x0 dot. And then this is a nice little hexadecimal serializer here. And then crop trailing zeros. I don't know. Oh, I guess it's like if you have trailing zeros, then it tries to skip over them. And then finally it adds the p plus an exponent, right? Wait, but see, that doesn't look right though, because there should be an integer after that last one, always. Right? So what's going on here? Let's just print out at the very end what we had here. So real to hexadecimal. Result is this. Why is the exponent not coming out? Like, we're only getting the sign of the exponent, but not the exponent itself. That's really suspicious. And it is calling a standard C library function, so it's very likely that we're doing something wrong in printf. So, wait, what is plus in printf anyway? Plus always sign. Oh, okay. So it's like you always include a sign even if it's positive. Otherwise, like %d will just give you a sign character if it's negative. But with %+d, you get a plus for positive numbers. Makes sense. Okay, so that's weird though. Wait, so are we just sucking at that? Let's just print out what the exponent is, and then we can kind of work from there. Yeah. Stir exp. And let me go and edit the source code here of this program so that we can just compile it right away when we boot up. Okay, so yeah, this is looking kind of suspicious. So real to hex, the exponent is 0. On the previous call, the exponent is 12, but we get +1. And here's -2, and we get -2. From -25, we get -25. So for negative exponents, it works, but for positive exponents, for 0, we cut off the last digit. Why though? That's so weird. But it sounds like a typical printf bug. So let's see. Let's just make like a little test program here to test it out. What was that? Plus D. So if we do -2, that should come out right. And let's do 2 digits actually. Okay. So that works in both cases. Although, wait, it was, yeah, it's not using printf, it's using sprintf. So I guess, let's try it this way. Make 2 buffers. And then buff1, buff2. See what comes into those. Oh, wait, what am I doing? I shouldn't have had the new line here. That's not right. Okay, so printf works, but sprintf cuts off the last digit of positive numbers when printed with %+d. Interesting. All right, so why might that be? Let's go look at sprintf. Okay, so sprintf is just a stdarg wrapper around vsprintf, sure. And he calls printf internal and then puts a null terminator at however many bytes we printed, I guess. So printf is supposed to return the number of bytes printed. So are we doing that wrong? Let's see. Let's just collect the return values here, because we returned the number of bytes printed as well, so we could actually print that out. Red 1 and oopsie doopsie. Red 2. Wait, so would that be wrong if we just did printf? Like, if we simply did like plus, or wait, %+d 12 and -12, then n1 is d, n2 is d. Look at that, they're different. So wait, what happens then? So when we do wait, where's the D implementation? Printf impl delegate to impl. Right, so where is this handled? I guess, where do we care about the always sign thing? Print signed number. Okay, so the returned number from this function is the number of characters written, and if it's a negative number, we +1. But if it is a positive number and we always sign, we print out a plus, but we don't account for it in the return value. Interesting. So I guess here we can just add always sign, right? That's a Boolean. I feel like that's kind of what the fix is. So, because if we always sign, then we have to add 1. Oh, now I lost that code, but we can quickly write it again. Just bear with me. Above 2, printf plus d12. Minus 12, and if we print these out, they should be identical. I would expect. Yeah, and even if this is not the problem that GCC is having, although it seems like it should be, I think we're still fixing a bug here. Yeah, so that is indeed this problem. Cool. So that's an easy fix. Yes, no, ACK, printf should, you know what, let's make a little auto test or unit test for this since we're here anyway. Put it in the test string maybe. Test case format. Do we have a thing for that already? I don't know. No, we'll just make one. Now I'm not sure that I'm in the right place, but string format uses append_vf. Yeah, so that's, I'm gonna put it here anyway, even though it's printf. It's a little bit weird to put that here. I just want to have some place to put it right now. So we'll do this, and expect equal ret should be 3 characters. And we'll say string ret1 should be equal to plus 12. Okay. That's a little bit of a weird test, but I just want to test it somewhere so that we don't lose it. And then maybe we should make a more extensive string format test suite somewhere. Okay, what am I doing wrong? Oh, I'm trying to turn ints into strings. Ninja test. And of course that runs the crypto tests, which will take forever. Can I just run the test string? Act tests test string. That appears to have worked. Yep. Cool. So let's add that and a little test case. Printf was not counting for sign character for plus sign with something like that, yeah. We have to include the plus sign in the numbered characters written. Otherwise, printf will put the null terminator too early. Nice. Okay, so with this fixed, maybe we can just rebuild GCC. So just to remove those, rebuild. And because we have to relink because this is statically linked. So just relinking GCC. And let's try again. Hopefully that was it. That would be nice if it would be so simple. Look at that. All right, so let's see if we can actually do some GUI stuff here. Just verify. GUI application construct. Wait, I put those in the wrong order. Make a window, GUI window, construct. It works. It works. Welcome to your Apache server. Show and oh, and we need libgui window, of course. Oh, I forgot to need to link against libgui and libgraphics and libcore and libipc. It works. Oh, went away when I clicked on it. Oh, I guess because it doesn't have a main widget. Let's just add one real quick. Set main widget, GUI label. Hello, friends. Wait, why does it look like that? That's so weird. That shouldn't matter though. Fill with background color true, maybe we have to set. Yes, okay. I feel like maybe the main widget should actually say set with fill with background color, or I don't know. Anyway, cool, it works. So that was our problem. And we have fixed printf to return the correct number of characters written for %+d. Great. So sometimes it's something small like that, and I'm happy that it was, because it could have been much worse in malloc or something. So nice to get an easy one sometimes. So this will be the end of the video because now it works. So thank you very much for hanging out, and I hope you saw something interesting. And I hope that GCC will keep working now, but I'm sure we'll find new issues in the future. Anyways, until then.